From 60% to 95% order visibility, how we rebuilt a logistics platform. Hey, welcome. In this video, we're breaking down from 60% to 95% order visibility, how we rebuilt a logistics platform. Let's get into it. Next up, moving on to the problem, when supply chain visibility software shows 60%. The company ran 14 carrier integrations across domestic and cross-border routes. Each had its own data format, update frequency, and error handling quirks. The result was a visibility dashboard that looked complete but wasn't. Orders disappeared from tracking for hours, status updates arrived out of sequence, and exception alerts fired too late to prevent customer impact. According to McKinsey's supply chain operations research, companies with fragmented tracking systems report 23% higher operating costs compared to those with unified supply chain visibility software. The cost is not just in fees. It's in the decision-making gap. When your operations team cannot see 40% of active orders, they default to phone calls, email threads, and gut instinct. The root cause was architectural, not operational. The original platform pulled each carrier API every 15 minutes. Carriers that throttled requests failed silently, and those failures were logged but never surfaced. The dashboard showed last updated 14 minutes ago even when the underlying update was empty. Now, let's talk about why digital transformations fail in logistics. Before writing a single line of code, we needed to understand why the previous rebuild had failed. That project ran 7 months, consumed roughly $340,000, and was abandoned with no production release. 67% of enterprise digital transformations miss deadlines due to governance failures, not technology failures. That pattern holds across our 500-plus project history, and this engagement matched it exactly. The previous vendor had technically solid engineers. The problem was software delivery governance, no formal checkpoints, scope that grew by approximately 40% mid-project, and stakeholder reviews that happen monthly instead of weekly. Software delivery governance is the unglamorous part of any project proposal. Vendors lead with architecture diagrams and case studies. They bury the governance section because governance feels like overhead rather than value. The honest answer is that governance is where projects survive or die. AI in software delivery makes this worse, not better, because AI-assisted development moves faster in scope ambiguity compounds with velocity. This is the delivery governance framework failure mode. Individual contributors optimize locally while the project drifts globally. Next up, let's talk about what is human-in-the-loop AI governance for supply chain software. Human-in-the-loop governance is a delivery methodology where human approval is required at every major decision point in a software project, not just at the end. For a supply chain visibility software rebuild, stakeholders review and approve the data model before it's built, the integration architecture before it's wired up, and the exception detection logic before it's deployed. Nothing significant moves forward without a documented sign-off. Reviewing a completed module for approval is rubber stamping. Reviewing a design before implementation is governance. For a full definition and practical examples, see our guide to human-in-the-loop governance for software teams. The rebuilt platform included several AI-assisted components: predictive exception detection, automated carrier scoring, and anomaly alerts. We landed on a tiered model for human oversight in AI systems. High-confidence exceptions trigger automated alerts immediately. Medium-confidence exceptions route to a human review queue. Low-confidence signals are logged for model retraining. This is responsible AI implementation in practice. Deploy automation where reliability is high, keep human judgment where it matters most. Now, let's talk about how we scoped the rebuild, blueprint sprint methodology in 5 days. Q Services developed the 5-day blueprint sprint as a structured scoping process for any significant software rebuild. Day 1 covers stakeholder alignment and success metric definition. Day 2 maps the current state and identifies integration gaps. Day 3 covers architecture decisions. Day 4 identifies risks and mitigation strategies. Day 5 produces a formal scope document with timeline, cost estimate, and sign-off. For this logistics platform, the blueprint sprint methodology surfaced 3 unresolved issues. Carrier APIs varied far more than internal documentation suggested. the existing data model had a flaw that would have broken real-time updates, and two stakeholder teams had conflicting definitions of visibility. One meant location data. The other meant ETA accuracy. Finding that in week 1 rather than month 4 is the difference between a successful project and another abandoned one. The full blueprint sprint process is documented here. The blueprint sprint methodology resists the temptation to start coding immediately by establishing that a signed scope document is more valuable than the first 5 development sprints. This project's sprint produced a 34-page technical scope document, a carrier integration compatibility matrix, and a formal definition of 95% visibility that all stakeholders agreed to measure the same way. Projects fail when success is defined differently by different stakeholders at delivery time. Now, moving on to building the platform, AI-augmented software development with governance. AI-augmented software development means using AI tools actively throughout the build cycle, with documented human review at each stage. AI-assisted generation handled roughly 40% of the boilerplate, data transformation layers, API client wrappers, logging scaffolding, and test fixtures. Human engineers wrote the carrier integration logic, exception detection rules, and the real-time event processing core. The AI governance framework for this project defined those boundaries explicitly before development started, so engineers knew when to use AI assistance and when to write and review everything manually. That boundary definition is a core part of responsible AI implementation, not an afterthought. The rebuild moved from polling to an event-driven architecture using Azure Service Bus as the message backbone. Each carrier integration became a dedicated Azure function consuming carrier webhooks and normalizing them into a common event schema. The main platform subscribed to that event stream and updated order state typically within 8 seconds of a carrier event. Next up, delivery governance framework that kept the project on track. The delivery governance framework for this project had 4 active components: weekly stakeholder demos showing working software, a scope changelog reviewed each sprint, a RAID board updated daily, and a formal go/no-go process for each deployment. Weekly demos are not status meetings. A status meeting reports on what happened. A weekly demo shows working software and forces a real conversation about whether it meets expectations. This project ran 16 consecutive weekly demos without a missed slot, and 2 of those demos surfaced requirement gaps corrected before they became expensive errors. Software project governance that includes working demos is materially different from governance that relies on written reports alone. At the end of each 2-week sprint, the stakeholder group reviewed completed work against the scope document. Any work outside scope required a written change request with a documented impact assessment. 3 change requests came in during the 5-month project. All 3 were approved and estimated before the work started. The project finished within 2% of the original budget. Software project governance isn't bureaucracy. It's the mechanism that lets you say yes to real changes while preventing uncontrolled drift. Next up, let's talk about results. Supply chain visibility software at 95% in 90 days. The platform went live after 5 months. Order visibility coverage moved from 60% to 95%. Exception detection response time dropped from 8.4 hours to 1.2 hours. The operations team's manual tracking workload dropped from 12 hours per week to under 2 hours. Customer credits related to visibility failures dropped by 78%. Total project cost was $287,000, including the 5-day blueprint sprint and all delivery governance overhead. Annualized savings exceeded $380,000 in year 1, producing a positive ROI before the project's first anniversary. The first change stakeholders noticed wasn't the dashboard. It was the exception alerts. Within the first week of launch, the operations team received automated alerts for 3 shipments that would have gone undetected until a customer called. In each case, they contacted the customer proactively before the delivery window was missed. By month 3, the operations team had abandoned the manual tracking spreadsheet entirely. That spreadsheet had existed for 4 years. Next up, let's talk about conclusion. Supply chain visibility software fails when the technology is treated as the solution rather than the tool. The real solution combines the right architecture, responsible AI implementation, and a delivery governance framework that keeps the project honest from day 1 through go live. This logistics rebuild worked because the blueprint sprint methodology caught structural problems before they became expensive changes. The hitl workflow automation kept human judgment in the right places, and the weekly demo cadence kept all stakeholders aligned without slowing delivery. The 35 percentage point improvement in order visibility was the outcome. The software delivery governance and structured scoping process were the method. If your logistics platform is running below 80% order visibility, the problem is almost certainly not the technology. It's how that technology was selected, scoped, and governed. Start with 5 days of structured scoping before committing to months of development. You'll know the full picture before writing a single line of code.